So here we are in SAGA-GIS 9. I've already loaded in a sample dataset, so this is the River Axe in southwest England. The DEM is based off the LiDAR data. We've got the land cover map from 2023 from the CEH National Land Cover Map, and we've got the long-term rainfall data. So this is the DEM here. This is the land cover map, which I've already gone through and reclassified to the standard default risk weightings for sediment export. And this is the long-term pattern of rainfall. Now, if we go into Tools and into Simulation, you'll see that there is the new SCIMAP Toolkit tool there. If we open that out, we currently have two options. The SCIMAP Fine Sediment and the Hydrological Connectivity Indices Collection. Now, SCIMAP Fine Sediment is the classic SCIMAP tool, but with some extra options that have come in version 1.1. The Hydrological Connectivity Indices Collection is a way just to get to the connectivity maps without having to run the full SCIMAP tool. So if we click on SCIMAP, we'll open up to our options. So at the top, we need to set our grid system. So we can see it's a 1 meter grid system. We can set our elevation model, which is our national LiDAR program, 1 meter DEM. Our erodibility, we can put in as our land cover map 2023 that's reclassified. Or we can put a default value of 1 in, not to account for land cover. This is useful if you're looking at where is most sensitive to changes from across the landscape. But here, we're going to put in a land cover map. And finally, in the input data, we're going to put in a long-term mean rainfall. We're then going to output our erosion risk, our connectivity, our accumulated erosion risk, our top 10% hotspot risks from across the landscape, and the erosion risk in channels concentration. So at the bottom, we can choose our how much area that which we need to have before we start having channels. The default for this is 0.8 kilometers squared. Then we can choose how we're going to pre-process our DEM. So previously we had the option of deepened drainage routes or fill sinks. So a few more options have come in to process the data in different ways. So, for example, fill sinks XXL is very good for large data sets. We can choose our flow direction method. We've got a few more options that come in here, but normally we work with a multiple flow direction algorithm. For the wetness index, you now have a choice between the classic topographic wetness index from Kirkby 76 or the SAGA wetness index. For the connectivity index, currently there's two options. There is the classic network index of connectivity that was in the previous version, and now there's also the percentage downslope saturated length. So we're going to use the standard connectivity indice. And for stream power, there's now three options. Previously, it was this top one, which is the slope times the area, but we can have a simplified stream area or stream power based on specific catchment area. So again, we're going to stick to the top of that, the default one there. Each of these different options we'll go into in a lot more detail in future videos. So that's all now set up. We click OK. That's going to go and run through and give us the output.